Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
The people that do the best in the drone or autonomous aircraft world are not drone people. It's people with problems that see that a drone can solve. Go to a Hollywood movie and see if you can see an aerial shot done from a helicopter. It just doesn't happen anymore. There were no drone experts in Hollywood. Some cameraman got out there, got tired of being in that giant vibrating helicopter and ordered a drone from Amazon and changed Hollywood forever.
Welcome back, everyone. Buckle up for this one and make sure you don't miss the thoughtful insights on mostly military but also commercial drone industry in the conversation that follows. James Poss is a retired United States Air Force Major General and now founder and chief executive of ISR Ideas, an intelligence and unmanned aircraft systems consulting firm. His distinguished 30-year Air Force career in military intelligence included combat experience in 4 wars. Before transitioning out of the military, General Poss was the Air Force's senior career intelligence officer. He's also a founder and former executive director of the Assure FAA UAS Center of Excellence team, where he led a coalition of 23 top UAS research universities in solving the FAA's top research questions for commercial and consumer drones. General Poss is a true thought leader in the world of unmanned aircraft systems, and we're very excited to share this interview with all of you. It's been really tough to choose a good call out at the opening of the episode because there are so many great ones. You'll hear General Poss talk about the military cultural imperatives that drove the adoption of drones in each of the branches of the U.S. military, a brief history of military use of drones as far back as 80 plus years ago, and how the capabilities of today's UAS systems compare to the drones that General Poss used in the Gulf War and over the Balkans in the 90s. He shares what drone use cases the military has made tremendous progress on, and also the missions where, sadly, this is not the case. You'll hear about 2 fundamentals that General Poss always goes back to in terms of using drones, which are, number 1, it's the data link stupid, and number 2, they're still just aircraft. We'll also throw a few acronyms and military designations such as ISR, MQ1, MQ9, RQ4, MQ25. So ISR stands for Intelligence, Surveillance, and Reconnaissance, which is the most common mission for military drones. And the other designations I mentioned are the different drone models that you can look up. Before jumping into the interview, let me just rattle off a few other topics that came up in the discussion. And those are the use of drones in the war in Ukraine, thoughts on where the military and commercial drone industries might be 5 years and 10 years from now, the topic of trusted autonomy and certified autonomy, military acquisition process, especially the software military acquisition process, and of course, advice to entrepreneurs and much, much more. Okay, so without further ado, here's the interview with General Poss. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. General Poss, thank you so much for being guest on the podcast. We're very excited to speak with you today. We will get into a lot of interesting questions on the UAS industry in general, but in particular as it relates to the military use of UAS. But before we go there, first question we ask, is there anything that very few in the industry agree with you on?
Ooh, okay, that's a good one. So, it kind of depends on whether you're talking about the commercial industry or the military, because I got a lot of people that disagree with me on stuff, and so I'll divide it into 2. How's that? So definitely
That's good.
On the commercial UAS side, I don't think that the FAA's plans for remote identification for small UAS are going to work. I get into a lot of fights, and I'm sure a couple of the guys that I very professionally disagree with will be listening to the podcast, but The FAA is planning to use essentially Wi-Fi and Bluetooth for remote ID, and I just don't see that congested spectrum being effective at the ranges that we're going to need in order to do remote ID. A lot of people disagree with me on that, but I think the solution is going to end up being either network using, ideally 5G, maybe LTE, or I think the ideal solution for remote ID is to find a particular frequency that we can use for that and that alone. But a lot of folks disagree. On the military side, I think I would proudly say I was probably the role model for the Navy 2-star there in Top Gun 2 that they called the Drone Ranger. I think drones are going to work. Back in the mid 2000s, I got a lot of discontent for saying that we really could use drones for counter-terror and everything that we ended up using them for. Nowadays, it's switched a little bit more, particularly in the Air Force. There's a substantial group of folks that think unmanned vehicles are the way to go. I guess the remaining 2 points of disagreement I have with my Air Force colleagues is, one, I still think that the remotely piloted aircraft network that we built up over the global war on terror is of great use. I think there's great utility for the MQ-9 still. I always kind of call it the DC-3 of drones, because if you remember the DC-3, first started flying back in the 30s as a passenger airliner, and then we dropped the 101st Airborne Division in with it over Normandy, which we never intended to do. And then we turned it into a gunship and a jamming ship. And I think the Navy still flies them on skis down to Antarctica. And I think we're going to see the same degree of flexibility out of the MQ-9. But most of the rest of the Air Force thinks it's not survivable in contested airspace. And we can talk about that in extensive detail about Ukraine. They disagree on that.
That's interesting. You bring up the DC-3 moment. One of our previous or earliest episodes was, in fact, about what might be the DC-3 moment for advanced air mobility in general, or alternatively, what's the Model T moment. So,
well, that's a good point. Maybe the MQ-9 is a Model T, and we're still waiting for our DC-3.
Okay. We'll get into some of these questions in the next hour or so. When you observe the adoption of UAS across the U.S. military branches, all the way back from some of your earlier experiences, even in the early Predator engagements over the Balkans 25 plus years ago. How does today compare to the expectations that you had, those 25 odd years ago? Where are we now on this arc of UAS adoption?
Yeah, it's kind of funny. My experience actually goes back to Desert Storm. I was attached to U.S. 7th Corps, and we were the one military intelligence unit that got Pioneer UAS, which is a Israeli aircraft industry's UAS, and sounds like a flying lawnmower. I always go back to the cultural imperatives, military cultural imperatives that have brought about the drone age. And it's good to start talking about the U.S. Army, because the U.S. Army kind of typifies the utilitarian approach to drones. The Army has always been a leader in unmanned systems, going back as far as, Desert Storm and all that. But it was the military intelligence community that just wanted a something that could see, a decent amount behind their own lines and guide the Army using sensors that were real time, which is why they came up with the Pioneer. And originally, the MQ-1 Predator was an Army system, and the Army saw it as a evolutionary system, whereas the Pioneer and their ilk could only fly within radio line of sight, which is no math in public, about 50 miles-ish. They were going to put a satellite terminal in the MQ-1 and allow it to fly, hundreds of miles before the Air Force and the Army got into our standard fight over, what's an airplane for the Air Force and what's an airplane for the Army. And we took it over in the Air Force. Now, the Air Force has only grudgingly gone to drones when they faced targets that they couldn't handle any other way. So really, our first experience with drones was back in World War II. I'm not making any of this up. We were in a joint program with the Navy to make remotely controlled B-17s to attack particularly tough German targets. And the first time we used it in the Air Force, the idea was the drone B-17 would take off, come to altitude, the crew would bail out, and then an accompanying B-17 would control it. And the crew went to bail out, and it exploded soon after, killing one of the Kennedy sons. And it flew fragments into the controlling B-17, which had one of Eisenhower's relatives on board. And guess who worked on both B-17s on the assembly line? None other than Marilyn Monroe. So
that's interesting.
But you go back to culturally why we were doing it. It was because we couldn't get manned B-17s into certain targets. And you see that throughout Air Force history up until the MQ-1. We had the Buffalo Hunters in Vietnam because it was just too daggum difficult to get photo reconnaissance conducted in North Vietnam when you use those extensively. So really the first time that the Air Force used a drone for something that they weren't forced to by enemy air defenses were the Balkans with the MQ-1. A lot of consternation over using it, but it had tremendous results, even more tremendous results when we armed the MQ-1. Oh my gosh, I guess we're up to 65 combat air patrols of the MQ-9. Massive part of the Air Force is now doing it, and you now see us adopting it. So it's a completely different. If I were to compare and contrast my experience, say in the Gulf War with the Pioneer, which we were just looking for something that would see a little bit beyond friendly artillery range, and now when we've got 65 MQ-9s flying, all of which are armed, are being not just flown from thousands of miles away, but the intelligence analysis is being done on multiple locations across the globe by multiple nations. It really is like night and day. And what also is dawn and dusk, maybe not night and day, is the attitude of the services before about drones. The Air Force is much more accepting than it was. The Army's always been accepting. You see the Army's aviation community a lot more involved than the military intelligence community. Navy, that's a whole different subject. Shore-based aviation thinks they're great. Surface warfare community thinks they're great. Naval aviation on carriers, jury's still out on that. But
General Poss, to the layperson, what's been the role of drones for the last 30 years? What missions are now done by drones on the military side that used to be done by aircraft? And what new missions are being done by drones that were never done before?
What I always tell people is drones have really taken over the dirty, dangerous, and boring jobs out there. So we kind of talked about the dangerous jobs with the remotely controlled B-17s and the Buffalo Hunter drones in Vietnam. You know, we lost large numbers of both of them. But really, where over the past 30 years, drones have really shined is in the dirty and boring missions. And that's overwhelmingly been ISR, intelligence, surveillance, and reconnaissance. If you were to compare an MQ-9, which is capable of flying, depending on the loadout, up to 30 hours with a manned aircraft, let's say an F-16 with a reconnaissance pod, boy, there's really no comparison. So the F-16, without refueling, you're going to be lucky to get 3-4 hours worth of coverage out of it, which means, pilot's got to get in the F-16. He's got to fly to the target that's, say 500 miles away. He's on target for, an hour and a half, 2 hours, and he's got to fly back. And then you would have to chain these F-16s to keep them over. And I did the math, and it was something like you'd need a full squadron F-16s to replicate the ISR coverage that you'd get out of a single MQ-9 that would stay up the whole time. So overwhelmingly, it's brought a real revolution to intelligence, surveillance, and reconnaissance. We've never armed drones before 2001. That has also had a profound impact. When we first armed the MQ-1, all it could carry was 2 Hellfire missiles, which are relatively small anti-tank missiles, have about a 15-pound warhead. So you're not going to they're not bunker busters. But it was great to have a long endurance intelligence, surveillance, and reconnaissance drone up that could pick the precise moment when that bad guy who you've been tracing for weeks gets into a car and goes down a deserted street and stops, and you can instantly hit him instead of having to call up a carrier and have them launch some F-18s from hundreds of miles away or divert a F-15 Strike Eagle that was supposed to be providing close air support to some SEAL Team 6 guys. You've got the capability to take it out. Now, the MQ-9 was an order of magnitude better because they could carry a lot more ordnance, fly for a lot more time, but it wasn't quite the revolution that the MQ-1 was. To be honest with you, I've been a little bit disappointed in the military in going to missions beyond long endurance ISR and light strike. The Navy's got the MQ-25, which is a carrier-borne drone, which will do air refueling. That's great. I think that's something that the services should explore more of to, perhaps make even larger tanker aircraft unmanned. But we're not seeing a tremendous amount of movement in areas where I think drones would be fantastic for the DoD. Small cargo delivery, at the front lines, delivering a couple boxes of 50 cal, a mile instead of making a soldier run under fire to do that. Casualty evacuation, you want to see some genuine heroes throughout U.S. military history. It's the medevac choppers and the pararescuemen that go in there. I think it would be fairly easy to unman casualty evacuation. Combat search and rescue, it's a dilemma that we're always faced in the Air Force. We lose an air crew, and you always lose the air crew in an area that's very heavily defended. In the case of the Serbian Air War, we lost an F-117, for God's sake, which was, stealth fighter and very highly defended. And then we had to send in a whole bunch of helicopters and C-130s that are in no way, shape, or form, good against advanced air defenses to get them out. That's another mission that cries out for drones to take over. And then I would also argue long-range cargo. Being able to fly long distances with a lot of cargo. There's so many advantages to do that with an unmanned system, but we're seeing the military react to that in slow motion. So,
why do you think that's so?
Luke, I wish I knew.
Is it technological or cultural?
I think it's mainly cultural. I mean, there are some genuine technological hurdles out there. I'll pick on the Air Force to begin with. So like the Army, the only people that thought drones were cool when we first brought them out were the Intel folks. And then when we armed them, it was largely the Intel folks that were doing the strikes, because we weren't trying to orchestrate hundreds of F-16s to attack a single target. It was one drone. There was always pushback from the manned aviators in the Air Force for quite a few years until they were convinced beyond a shadow of a doubt that this was going to go. But the folks that were involved with it and eventually came around to seeing that they were a good idea were largely Air Force intelligence and the Air Force fighter community, whereas the Air Force transport community, the tanker guys, really weren't exposed to it. And I'm starting to learn that if you're trying to sell a new technology to an expert in old technology, so you're trying to sell unmanned technology to a manned pilot, boy, they've got to have a tremendous amount of experience with it before they buy off. So Air Force has got a great program we can talk about later called Agility Prime that's designed to leverage civilian advancements in the electronic vertical takeoff community that's doing great. Slowly but surely, we're starting to make impacts into other Air Force lines. But keep in mind, no matter how you slice it, when you get up to the Air Staff or Army Staff or Chief of Naval Operations, nearly everything's about money. And the problem with drones is no matter how you slice it, they're always threatening a manned aircraft program. The real reason the Navy's not adopting carrier-based drones is because their version of the F-35 is not doing well. And they knew daggum well that if drones do well, they're going to lose F-35.
If I can draw a parallel, looking at the conflicts in Iraq and Afghanistan, that was really the catalyst for a lot of the ISR drones, both in the low end and the high end. So perhaps there needs to be another necessity, another forcing function that will highlight the need and importance of UAS and these other missions to convince all of these, quote, old experts that new technology is probably better.
Yeah, well, and like I was talking about before, unfortunately, in the Air Force, it's tended to be tremendous losses on the manned aircraft side before we go around it. But what I always like to tell people is, a lot of people come at you and, say drones are only good for, uncontested airspace and they'd never survive contested airspace. But modern drone warfare in the Air Force was actually born in the skies over the Balkans, which was contested airspace. We really learned how to target the MQ-1 Predator in contested airspace over Iraq. And we really haven't lost that many unmanned vehicles flying in contested airspace for that long as you think. We've lost more remotely piloted aircraft than we've lost manned aircraft in that time period, but the losses haven't been excessive. So.
Staying on the high level, what are DoD priorities when the DoD looks in the next 5 years? Where is it focusing? What's likely to arise from these priorities in terms of UAS systems and technologies?
Yeah, that's a great question because you can always ask about forecasting the future in 30 years or so. It's difficult to do. You can forecast the DoD's future in 5-year chunks because we have to budget in 5-year chunks. We'll very soon see the FY24 budget, which is going to be a full 5-year budget. But what I expected in the Air Force is to see the influence of our new Secretary of the Air Force, Frank Kendall, who's an acquisition veteran, knows how to get things done, and he's a big supporter of unmanned systems. The Air Force has done a study called Next Generation Air Dominance, NGAD, and I don't know the full parameters of the study, but whatever it came up with, it said that we need a much more stealthy 6th-generation fighter that's going to be very expensive, about $200 million a copy. And we're also going to need quite a few of much less expensive remotely piloted aircraft in order to complement this as a kind of a system of systems approach to air dominance. And I think we're going to see the Air Force finally put money behind their loyal wingman concept. And that's a concept that Secretary Secretary Kendall has already said we're going to come up with a loyal wingman for our 5th/6th generation fighters, and then we're going to come up with a loyal wingman for the B-21 stealth bomber. We're still not sure what the role of that loyal wingman is going to be. I'm hearing that the initial iteration of the loyal wingman is going to be as kind of a missile truck. So you'd have one F-35 in formation with 4 loyal wingmen, and F-35 can only carry 4 air-to-air missiles internally and stay stealthy. The other ones will be like an extended magazine for them. But the interesting part about the Air Force, and they've actually put quite a bit of research into this, is they've been doing research on Skyborg, which is an Air Force Research Lab program. And Skyborg was designed and it was just canceled a few weeks ago in order to make way for the production version of the loyal wingman. Skyborg was designed to develop the autonomy core system, ACS, which is kind of the central nervous system for what could be a whole family of drones, and then experiment with dropping different brains into this autonomy core system. So the idea being they're using mainly a General Atomics MQ-20, which is a jet-powered variant sort of the MQ-9, which is kind of an autonomy core system, which has been operating very well, and they'll drop a brain in that lets it do ISR fairly autonomously, or drop a different one in that lets it fly welded wing with a manned aircraft to be missile truck for it. But I know that you're going to see the Air Force put a substantial amount of money towards these 2 loyal wingmen, which I think is great. The Army, I love the United States Army. They're having trouble making their mind up on one of their big programs, which is the Future Tactical UAS. They've been at it for 3 years now, and I hope that they're going to go ahead with an acquisition decision on that. And the FTUAS is going to be kind of a brigade level UAS, a mid-sized one to replace the RQ-7 Shadow. It's probably not going to be as advanced as the Air Force. It's not going to have a great degree of autonomy. The Navy is going to proceed with its MQ-25, hearing that they're going to cut large numbers of their MQ-4 Triton, which is a land-based drone, the Navy's version of the Air Force Global Hawk, just because of production issues. The MQ-25, barring some miracle in the Navy budget, is going to continue to be a tanker. Don't get me started on that. And not an ISR strike aircraft, which I'm convinced that the nation needs a carrier-borne ISR strike aircraft more than any other drone. And then the Marines are the interesting ones. Marines are going to be buying the Air Force MQ-9, and they're going to be using them largely in a wide area intelligence, surveillance, and reconnaissance role. So think putting up electronic warfare sensors over a very large area to collect intelligence and jam enemy radars as a Marine force comes into land. And it's also going to be used as communication relay, because the Marines aren't counting on having satellite communications available when they go out. So 5 years, that's what's going to happen, and we're going to see money going against that. So great progress, particularly on the Air Force side.
Yeah, absolutely. Just to pause on the loyal wingman concept, is the term misleading a little bit, do you think? Originally, the concept of a wingman and in general, the combat formation flying has been around mutual defense, and originally primarily against short-range weapons calibrated for the capabilities of the good old eyeballs, right? So that's why you had airplanes in the kinds of formations that they have been flying historically, to a certain extent even today. But in the future, with different mix of weapon systems on the modern battlefield, are the loyal wingmen really likely to be flying on the wings and in close proximity to the host aircraft, or will that be some kind of commanding and controlling from a much larger distance?
Well, yeah, that's the billion-dollar question. The Air Force is pretty sure that they could develop an actual loyal wingman, I think, that would meet both yours and I definition, an aircraft that would fly relatively close to a manned fighter and would respond to commands from that manned fighter. As far as what you would have it do, I think the jury's still out on that. Originally, the Air Force was saying loyal wingman would do, very simple tasks such as scan this sector with your radar, watch this target, launch on this target. It looks like what we're getting is, and we can talk about this more, but a big question of trusted autonomy. One thing to have that lieutenant out on your wing and pretty sure what he's going to do. It's quite another thing to have a robot on your wing and
absolutely
pretty sure he's going to stay welded wing, but you're not completely convinced. So there's a lot of nervousness about that. And the Air Force response to that, I think, is a great response, and they're going to make a adversary air version of a remotely piloted aircraft. They've just picked up Blue Force Technologies to develop a prototype. And so these adversary air aircraft, are going to simulate, Russian and Chinese fighters, but they're going to fly in their own formations, not mixed with manned aircraft. They're going to fly realistic tactics, simulating what the enemy would do. So we'll have an answer to a lot of questions there without having to, stick these in close proximity to F-35s or F-22. So we'll know if they can fly in combat formation. We'll know if they can make decisions on their own in those formations, and we'll know what the risks are in a very few years after that. An interesting counterpart to it, which I wouldn't call a loyal wingman in any way, shape, or form, is the General Atomics Defender concept. They're advocating not flying these things in close formation with manned aircraft, but giving entire tasks over to the drones. And in this case, they're putting their defenders out as a high-value air asset, have a defense. So there's a whole bunch of what the Air Force calls high-value asset, airborne assets, RC-135s, AWACS, tankers, jamming aircraft that stay a good bit back from enemy defenses. It's expensive to cover them because you've got to keep F-15s or F-22s out to do that. And General Atomics concept is just turn that over to drones and do it on their own.
Let's call it the metrics of warfare. What's the greatest value of a drone to the battlefield? Is it because we're going to do something that we've done in the past less expensively with less loss of life? Are we more effective than what we've done in the past? If you were going to break it down, what are the metrics that are most improved?
Clearly our risk to human life is much down, but because we don't have pilots on board. So that's one metric. The other metric is being able to do things with drones that you just couldn't do with a manned aircraft, like fly for 30 hours straight without refueling.
What's the net benefit of that?
Well, the net benefit of that is you can surveil a target continuously with somewhere between 2 and 3 MQ-9s indefinitely, 365 days a year, 24/7, where it would take 18 to 24 F-16s to do the same thing at considerable more expense with considerable less effectiveness because you're constantly changing aircraft out, whereas you've got generally the same aircraft for a 24-hour period with the MQ-9.
Are we arguably winning wars faster because of drones, or is it generally we're less expensive and we're saving more lives, but the general net effect is the same?
It's less expensive and we're saving more lives, but the general net effect is the same. Let's examine a war that nobody thinks about anymore, but used to be very important. That's the war against Al-Qaeda. We took over the entire nation of Afghanistan back in 2001 at great cost to root out Al-Qaeda, and they just moved across the border. It turns out they were in Pakistan. The U.S. intelligence community never gave up. And, you can't talk about it in great deal, but the MQ-9 was and is a tremendous participant in that war. When was the last time you ever thought about Al-Qaeda or heard about an Al-Qaeda threat? Probably been a while, but we've been at it for 20 years. It goes back to being able to stay on target for an extended period of time relatively cheaply. And it's taken 20 years to finally suppress them, but, we did it, and we did it with very small loss of Allied lives.
Zooming in a little bit into onto the UAS systems in general, how real is this affordability, capability, reliability trade space in UAS? Yeah. And can you bring up some examples from the past where this was really obvious and painful?
Yeah, I've got a couple of phrases with drones. First one is this the data link stupid? Because no matter how you talk about autonomy or anything like that, you're eventually going to have to talk about data links. And the other one is they're still airplanes. You get these people that think we can have remotely piloted aircraft that can carry 10,000 pounds of ordnance from, the west coast of the United States over Beijing, and they can do it for pennies on the dollar. No, that's a B-52 you just talked about, and that's a large aircraft, and they're expensive. True, you save a little bit of weight by not having to have ejection seats and controls and having to pressurize the aircraft, but they're still aircraft. So if you want them to come back multiple times and you want them to be reliable to where you can fly them in the States over civilian areas, that's a fairly complex aircraft and a fairly expensive one. So I'm a little bit dubious of the Air Force has got this low cost attritable aircraft. I'm a little bit dubious that we're going to be able to build a reliable, durable, remotely piloted aircraft an order of magnitude cheaper than we do manned aircraft. Now, you can get into the argument that you could afford to give a remotely piloted aircraft a minimal amount of stealth characteristics, which is horrendously expensive because you can lose X amount of them. But they're going to end up costing about what a Block 10 F-16 costs. So.
What do you think are some of the gaps or technologies that we should go and innovate on to perhaps bridge that gap? I'm not talking in particular about LCAT, but some of the other technologies that would perhaps even break that trade space.
We found out a lot about composites, particularly with the MQ-9 program. MQ-9, MQ-1 have got a lot of composite stuff in there. I think it was really an aircraft that got the aircraft logistics and maintenance community comfortable with composites. And done right, composites are very reliable, cheaper in a lot of instances than using aluminum aircraft. So I'm thinking advanced manufacturing techniques, both additive manufacturing and composites is something we should look into. And I would argue that it may be easier to do that with unmanned aircraft than it is with manned aircraft just because of the certification requirements. The other thing I'd look into is generally what is the most expensive part of the aircraft, which is the avionics and sensors on board. We need to look into what's good enough, vice what's the absolute best answer for putting in that aircraft. And again, there's quite a bit of transference from the commercial UAS community into the military remotely piloted aircraft community that we could do. So, for example, we were talking about remote ID. Remote ID has led to the size of, quarter-sized remote ID transponders that work just as well as microwave-sized transponders do on military aircraft. That's an area that you could put in. But I think most of the research is going to be going to where most of the research has been going, which is into trusted autonomy and maybe later artificial intelligence.
So speaking of which, what's the state of the art on the front of trusted autonomy? What approaches have you seen that have the most promise?
Really, the only aircraft that we've got, enough hours on that uses a great deal of autonomy that I would be able to comment on is the RQ-4 Global Hawk. And, we've been flying that since 2001. And unlike the MQ-9, which, pilot is actually flying and, he's controlling the throttle, you just tell the RQ-4 where to go. Yeah, we've had a few moments with the RQ-4, but generally it's been one of the safest aircraft, that we've had. If there's a fault with it, it's, for example, we lost one, about 9 months ago because the crew had reset the software in the ground control station as it was on approach, and the aircraft came in thinking it was at the altitude when the GCS was set, which was 4,000 foot off from where it was, and basically tried to land 4,000 foot over the runway, which would have been solved with a simple, hey, check your radar altimeter before you land kind of stuff. But generally, the amount of autonomy in the RQ-4 has been very successful for the Air Force. We just don't have enough time on more advanced autonomy other than, the Skyborg system that the Air Force is flying. We're just going to start flying aircraft that have a much greater degree of autonomy, and we don't have enough hours on them yet because they're still prototypes.
Of the 80% of the military dollar that it goes into the drones, who are the top manufacturers of those drones?
The big manufacturers are General Atomics, makes the MQ-9 and MQ-20. Northrop Grumman makes the RQ-4. Boeing has just gotten into the game with the MQ-25. Lockheed has got the RQ-170 that the Air Force has released, which is a stealth drone. But as far as volumes of sale in the American market, it's probably General Atomics that has got them all.
And is it a good business to be in? I mean, let's say vis-a-vis aircraft. Good business to be in?
Yeah, it's the future of aviation. It just depends on how long we're going to take to get there. We've proven beyond a shadow of a doubt that on the military side, for long-term intelligence, surveillance, and reconnaissance, there's no other choice but drones. I think we're going to learn very quickly as the loyal wingman comes up for very dangerous missions that drones are the go-to. The one I'm waiting to cook off is long range and short range cargo delivery.
So, General, if you had to put those use cases in order, right? We've got the ISR covered now, and we have loyal wingman kind of combat autonomy strike systems somewhere out in the future. What is in between? Or perhaps you might rearrange that, but how would you rearrange these use cases?
So the ones that we're most most likely to put money into and you're most likely to see is definitely, ISR is going to continue at a certain level. I think loyal wingman at the very, very low end, where you've got a loyal wingman that's just providing ISR to a manned aircraft or providing extra missile capacity, is definitely going to work. I think the Air Force is going to find that autonomous aircraft are capable of taking on quite a few combat missions from manned aircraft, and that's going to go well. The one, I hate to keep harping on it, but the one I think we're falling behind on is Air Mobility Command interest in unmanned tankers and cargo aircraft. And the problem with that is not that we can't unman tankers and cargo aircraft and get them to fly and land and take off. The problem, particularly for cargo aircraft, is the ground operations. It's one thing to taxi an MQ-9 at Creech Air Force Base where there's nothing else flying on Creech but MQ-9s, and the controllers are trained in it. It's quite another thing to land an unmanned C-17 at Frankfurt International Airport, where you've got every airline known to man and signs are not marked for ground taxi and all that. So I think that's what's holding back large cargo. Mm-hmm. But the advantages of unmanned cargo are just astounding.
Who's going to lead Luca, we've talked a lot about the applications in cargo with advanced air mobility. Who's going to lead, the commercial or the military, when it comes to advanced air mobility with cargo?
I hope that Air Mobility Command and the cargo aircraft industry, FedEx, UPS, those guys are going to link arm in arm and approach it. They've done a study together that's, probably about 5 years old, to figure out the economics of it, and they were pretty jaw-dropping. So they figured out flying cargo 747s versus unmanned, purpose-designed unmanned aircraft between Memphis and Narita in Japan, and you can basically keep that going with, I think it's 7 remote pilots, and if you wanted to keep it going with air crew, I think it was 40 air crew, because of crew rest and all this kind of good stuff. The other interesting thing is a purpose-designed unmanned cargo aircraft is about 20% lighter than a manned one, because you don't have control surfaces, seats, or anything. You also don't have to pressurize an unmanned cargo aircraft, or if you do pressurize it, you pressurize it with nitrogen so you can carry hazardous cargo. And if you're not pressurized, the hull doesn't have to be as thick, and you can fly at 45 to 50,000 feet instead of 35 and save a tremendous amount of fuel. But the study did cite that the main problem is not flying, it's ground taxi and integration with manned civil airliners around the world.
Right. All right. Well, let's pivot to Ukraine and the lessons learned from the Ukrainian war. How do you explain the initial success of tactical UAS systems there, and what raised your eyebrow the most?
Yeah, the initial success was Russian stupidity. And if you find a lot of the stuff that you see online about commercial drones being used by the Ukrainian model aircraft enthusiasts and the Turkish TB2 remote aircraft, was when the Russians tried to make a thrust down from Belarusia to Kyiv, and then a thrust from Russia coming into the northeastern side of Kyiv, and they thought that they could descend in an armored thrust, and they were just eviscerated by Ukrainian ground forces, and Ukrainian drones played a significant role in that. I think the problem was, having been part of an armored attack in Desert Storm, was the Russians just couldn't bring up their air defense assets and their radio electronic jammers in that kind of scenario like they would in the siege warfare that they're doing now. So as a result, these Russian ground forces were uniquely vulnerable to Ukrainian, javelins, drones, and stuff like that. I think, like a lot of militaries, the Russians had kind of wished away drones and really hadn't put a lot of thought into it, although they don't really have an excuse for that, because they came up against drones quite a bit in Syria, but the threat of drones had not gone down to the very lower levels of the armored forces in Russia. I think what we're seeing now, where the Russians have gone back to something that they could do, which is refight World War I by pummeling everything with artillery, that these are much more static lines, and the Russians have been able to, from a technical perspective, see what kind of technical problem they're going against, and they've now got their electronic warfare guys up front, and they've deployed a lot of their air defense systems, which are not perfect, but better at taking out small drones, and you're seeing the Ukrainians lose a lot. But when they were able to go against those 2 armored thrusts, they were very effective, even commercial drones.
Right, absolutely. What I'm thinking about, and I would love your thoughts on it is we always tend to prepare for the next war based on the lessons learned in the previous war. And a lot of eyes are now pointed towards Ukraine and the effectiveness of tactical UAS or just broadly UAS systems there, and might be thinking, oh, gee, this is a great time to acquire some of these systems and prepare for the next kind of similar war. But the U.S. might need to look a lot different in the next conflict than what we've seen in Ukraine, just based on the reactions that we can expect to be on the counter UAS side. How do you envision this cat and mouse game ultimately leading to changes in the design and how UAS systems are employed in the next war?
Yeah, well, I go back to my original two sayings. So it's the data link stupid and they're still aircraft. So the most effective systems that the Russians have against the Ukrainians are their radio electronic combat folks. And Ukrainians are using mainly civilian drones. Those are communicating by Wi-Fi. The data link structure is well known, so they're jamming, very effectively jamming them. The military drones are doing a little bit better, but people are going to realize that radio electronic combat, electronic warfare is the most effective tool. And so we've got to pay a lot of attention to getting data links that are capable of looking through. I personally would like to see how Starlink, Elon Musk's low Earth orbiting internet network works. I think that's going to be pretty jam-proof, done correctly. And I think that might have a big impact. And there's a whole bunch of other stuff you can do in data links. The other side is they're still aircraft, and just as you would not want to fly an Apache, straight into an SA-11 surface-to-air missile the Russians have, you wouldn't want to fly one of the future tactical UAS systems into that. So I think even ground-forced UAS are going to have to start looking at more low observable characteristics for their airframes, or kind of like what we talked before, making much cheaper ones and having them swarm, quote unquote, adversaries. I also think autonomy is a great way to get out of both of these problems. That if you have an autonomous drone, it doesn't always have to communicate back. It could communicate on its way back to base. It sends you pictures vice while it's doing it. Autonomous UAS can also work together and fly in a formation of 5 or 6, and 2 of them are jammers, and one of them's got a radar homing warhead, and one of them is the actual ISR thing. And when it detects a surface-to-air missile, it does this routine and does it automatically without having to have a data link. So
the future is characterized by a lot more sophisticated counter UAS systems in general, with all kinds of jamming systems. Which do you think is more probable, that the future UAS become attritable, expendable, they're used in swarms, and people recognize, hey, we don't really have a chance against these solidified and more sophisticated defenses, or do we go down the path of more sophisticated sensors, more expensive sensors, and therefore the drones start going down the path of traditional aircraft in terms of just expense, weight, complexity?
Well, I think we're going to do a little of both. And when you really look at the problems when you're talking about coming against an enemy integrated air defenses, from NATO's perspective, the problem is really the large radar-guided surface-to-air missile systems, the SA-10, SA-20, and all that. And I think we're going to develop drones that are capable of working largely autonomously, don't have to use exquisite sensors that are going to make those surface-to-air missile operators' lives hell. These things are going to show up. There's going to be a bunch of them. They'll be all over the place. And once you take the large radar-guided surface-to-air missiles out, you're left with enemy fighters, which NATO kind of hopes you fly fighters against them. And then anti-aircraft artillery and the shoulder-launched missiles, all of which you can fly over. They've got limited ranges out there. But I don't think you're going to see extremely expensive stealth drones used in large numbers against that. I think you're going to see reasonably expensive collaborative UAS used in reasonably large numbers against those kind of threats.
Mm-hmm. General, what's the biggest unfulfilled need on the military drone side that a smaller company potentially could fulfill that you don't think people are paying attention to today?
Well, it's getting a lot of attention, but autonomy and artificial intelligence is something that the big companies are just not paying enough attention to. And you kind of saw that when Air Force Research Laboratory had its alpha dogfights, it's about 18 months ago, to where they had a whole variety of companies come in, and they were supposed to come up with AI that could out dogfight an F-16 flown by a Air Force Weapons School grad, and they did. And the companies that did well were smaller companies out there. And I think it was Heron Aviation was the one that won. I think they've been since bought by Shield AI. But that's something where, a younger group, a smaller company that can move fast in AI I think would do very well.
And in this case, the use case was out OODA looping the other pilot. So what are the other use cases in AI that a small company could target?
Well, I mean, they're all of them. I mean, there's a lot of, stuff that we have to do on the commercial side that we're already working on for AI. So, surveilling a large area, tracking individual cars out of a bunch of other cars, mapping using AI, is another great one. But the ones that the military are always going to be concentrating more on is trusted autonomy that we talked about, being able to fly reliably in formation and execute tasks in a reliable way that would make sense to a human. Then the collaborative work that we talked about, where you've got drones that are able to figure out, one of them's got a anti-radiation missile, one of them's got a radiation sensor. How does that work? I think where smaller companies are going to struggle with is airframe manufacturing, engine manufacturing, just because that there's just so many certifications required for that it's difficult to do that as a small company.
So another challenge that we think small companies will have is how they interact with the U.S. acquisition, the military acquisition machine. How is the acquisition machine ready for fielding these UAS systems and these, sophisticated parts of the technology stack? How does the military buy that?
I got asked that question by a client just a couple of weeks ago. So the military is going to do good at stuff that it knows about. So it will procure airworthy airframes and engines and everything like that. I think problem that nobody's got a grip on is, the tremendous amount of signature libraries and the tremendous amount of management that machine learning and AI is going to take. And I don't think the world has enough experience with that, let alone the military. Just like, the FAA is struggling with certifiable autonomy, military struggling with trusted autonomy. How do you make sure that machine's going to do what you think it's going to do that we're just not prepared for? On the positive side, the Air Force is definitely trying to do a much better job of reaching out to smaller companies. We've all know about SBIRS, which is purposely designed to bring in small business. And we've had that for years. The military is shifting a lot to these other transactional authorities, OTA, which is a NASA invention, which if you're a member of an OTA consortium, and there's dozens of them, the Air Force can essentially write in plain English what it wants in 2 pages, and it can get you working on that to deliver a prototype. Acquire a production aircraft out of it very quickly. And then I've been very impressed so far with the Air Force Agility Prime program, which has been purposely targeting the civilian electronic vertical takeoff community. And they haven't been giving out a tremendous amount of money, but they've been offering Air Force airworthiness, expertise, access to Air Force ranges, access to Air Force air crews for expertise. And it sure sounds like it's been having a great impact.
Yeah, totally agree. But just staying on the acquisition topic a little bit more, if you don't mind, can you recall any examples where the DoD purchased software from companies, non-prime companies in particular? What is the DoD software acquisition strategy?
Hopefully to avoid it. Yeah, so we've been all over the map on on software, and our cross to bear in Air Force intelligence was the Air Force Distributed Common Ground Station software, which is the software that all of our drones or space-based assets are hooked up to, that allows Air Force intelligence professionals to figure out what's going on with the sensors. We tried everything with that. Plan A was to get a large vendor, and they were responsible for everything, integrating everything, and that didn't work well. We went to where the government was the lead system integrator. That didn't work well. What we're trying now is sort of the Apple and Microsoft approach to it, where we're going to state this is the operating system, this is a software development kit, this is how you hook it up. If you've got an app or an idea, here's the app store, and that's working a lot better. The particular problem you run into, particularly when dealing with the intelligence community and the DoD in general, is not only do you have to have genius code writers, but you have to have a secure compartmented intelligence facility to do that, and you have to have clearances for people, and that is often tough for smaller companies.
Why is the model of government as an integrator, why did it not work?
The basic problem is, if you got the government as the integrator, then the companies are doing it, everything becomes an integration problem, and it's not their problem, and the government messed it up. So the example we had in DCGS is we had to connect to a daunting number of sensors on aircraft, and that's the hard part of it. If you've got a company doing it, you can put the thumb screws on and just not let them out of the room until everything's integrated. But if the split authority, then industry decide whether that's an integration problem. The Air Force is going to do that.
Makes sense.
Two questions, if I could, before we get to our closing. What's the greatest improvement on the commercial UAS side that's come from the military?
I have high hopes that when the FAA publishes its beyond visual line of sight rules, that they're going to adopt a lot of the procedures and rules that we've been using in the military, because we've been flying BV loss, since Vietnam, and it's been a tough fight. But I think the FAA is coming around to a lot of the stuff that we're doing in the Air Force is going to be applicable on the civilian side. But the problem in getting greater applicability on the military side to the civilian side is the way the FAA has set up rules. And basically the Part 107 rules, force civilian drones to fly in a manner that, the military would never do. They can only fly up to 400 feet. They must stay within visual line of sight of the pilot. They can't go over, 90 knots or something like that. We're just not, that's just not military viable to us. So the civilian world has kind of developed its own tech. But once they go BV loss, there's a tremendous amount of military technology that they could use on the commercial side.
I'm curious, what are some of the methods that you hope military BV loss translates into civil BV loss?
Yeah, so our primary method is already met with success with the FAA, and that is to use a ground-based sense and avoid system, aka a radar, to spiral up from where the remotely piloted aircraft is taken off to Class A airspace, 10,000 foot, which is controlled airspace. And the FAA is responsible for separation, and we just file an instrument flight rule, fly in 10,000 feet and do whatever we're going to do. And many thanks to the New York and California Air National Guards for figuring that out for us. And so if you've got a drone that can get up to 10,000 feet, thank you, U.S. Air Force. We've already figured out how to do that. The problem is lower than above 400 feet and lower than 10,000 feet. Unfortunately, we tend to do that in controlled airspace, which isn't helpful because that's all controlled by the military, or we do it in combat. Generally, particularly if you talk to the MQ-9 community, they'll argue that they're an order of magnitude safer flying between 10,000 and 400 feet than just about any other aircraft, because they've got this tremendous sensor that could detect another aircraft at 30 miles if they had to. The other key is to making sure that everybody's got ADS-B on board so that they can see from electronic measure where they are. The Navy is flying an airborne sense and avoid sensor on their MQ-4 Triton that the FAA has been following very closely, because the Navy has to fly due regard, quite a bit out there. We're hoping that radar is going to do well. But what you're not seeing in the military is this tremendous attention being paid on, for all these, tremendous airborne sense and avoid systems that the FAA is probably going to make commercial drones apply with.
You were obviously very successful in the military, and you've been very successful in your transition to the commercial world. There are an awful lot of people who have made that transition. So 10 years out, roughly, since you've retired, what advice would you give to those who are getting out on the commercial business world, to those who are transitioning from the military? What would be 2 or 3 pieces of advice you'd give them?
Oh, yeah, I'd love talking about this. So you got to start plotting your escape early. It's the big one. And I started, about 2 years out, trying to figure out roughly what I wanted to do. For retiring generals, and it's the same for, colonels and whatnot, you can either go work for the usual suspects, Boeing, Lockheed, those guys. Or in my case, I could have gone back and worked for civilian intel agencies like National Security Agency, or, start out on your own. And I opted to start out on my own business. And I was very careful to start paying attention to the commercial market for what I thought were my marketable skills, which were dealing with, intelligence, surveillance, and reconnaissance and unmanned systems. And I look for opportunities to speak, get to know people in this realm. And in my case, it led to a very lucky meeting between me and Dr. David Shaw of Mississippi State University. I'm from Mississippi, and he was looking for someone to put together their drone research center bid. And I, eagerly took that up. And that allowed me to learn in great detail the civilian FAA version of how they approach drones, and compare and contrast that with the military side. And that's generally what I built my post-Air Force career on. If you're getting out, look to see what those military skills are and see what the civilian translation is of them, and then spend time learning how the civilians view your skills and comply with that. Where I've seen guys that don't succeed is, they think they could force the FAA to do things the Air Force way, or company X, Y, or Z, is messing it up, and we do it better in the Air Force, and that rarely works.
Yeah, good luck with that.
Yeah, particularly with the FAA.
General, if you fast forward, we talked about the 5-year horizon. If you extend that to maybe 10 years out, what does the industry look like?
Ooh, okay. So I'll give you a dual answer. So on the commercial side, I probably shouldn't say this. I'm going to touch wood while I'm saying this. So on the commercial side, I'm hoping that we're going to have full BV loss rules out there, that the FAA is going to come up with very rational methods to do airworthiness for larger than 55-pound UAS, and is going to slaying the dragon on figuring out how to certify drone carriers. And I think that's very doable. Hopefully in 10 years, you're going to see the dream of eVTOL realize, that you're going to see a good bit of package delivery being done by drones, that it's going to be routine to have drones are going to do most of our geospatial mapping work and all that. And the first responders are all going to have drones, and they're going to fly beyond visual line of sight. And okay, I'm going to take my hands off the wood. And then on the military side, 10 years from now, I'm very confident that we're going to have functioning autonomous collaborative aircraft. And they're going to be a lot cheaper than what they are now, and they're going to be capable of taking on pretty complex missions and pretty dangerous missions, and it's going to really be a force multiplier for us.
So that being the case, when are we going to see the most dramatic reduction of pilots going from military to the commercial airlines?
Yeah, that's that's something that bears a study. I think we're already seeing an impact of that, because the Air Force in particular is already producing a smaller number of pilots, and not just because we're training a lot of drone pilots, but we have fewer aircraft, and then you couple that with the fact that civilian air schools are not producing as much, and I'm a little bit worried at the 10-year point about how we're going to keep our airlines going, because they've gotten used to those military pilots.
When are we going to see fully autonomous operating aircraft in the military and the civilian world?
Well, I could argue that we've already got autonomous aircraft flying at least at a prototype level in the military. On the civilian world, if you believe what the package delivery guys have been saying, and I do, the vast majority of those package delivery aircraft are largely autonomous. Well, I'm not going to name the company, but there's a big name company that's expecting a remote pilot is going to supervise 10 to 20 cargo aircraft, which means that they're flying largely autonomously out there, and it appears to be going pretty well, at least in the lab. Challenge, of course, is getting the FAA to agree that that degree of autonomy is worth the risk to it. And I think the jury's still out on that.
If we had a 25-year-old entrepreneurs and they love the advanced air mobility space, drones and the like, and they said, General, give me one piece of advice on starting a business, what would you tell them?
I'd tell them something that's probably counterintuitive to them. I tell them that the people that do the best in the drone or autonomous aircraft world are not drone people. It's people with problems that see that a drone can solve it. Play the game that I always play. Go to a Hollywood movie and see if you can see a shot that's being an aerial shot done from a helicopter. It just doesn't happen anymore. There were no drones experts in Hollywood. They wouldn't have known about it, but some cameraman got out there, got tired of being in that giant vibrating helicopter, and ordered a drone from Amazon and changed Hollywood forever. But you'll see that time and time again. Bridge inspections and highway inspections is not being done by drone people. It's by civil engineers that just don't want to get under bridges anymore.
Right.
Problem first, and then apply a drone to it. Don't go get a drone and then look for a problem to solve.
Love it. And okay, so I'm one of the 5, and I said, okay, what's one problem do you think, General, that is not being addressed right now, or that I could focus on?
And I'll say this till I'm blue in the face. The FAA will let you fly a large UAS in controlled airspace as long as you spiral up there. And that's where we do 99% of the Air Force's work. So there's a lot of stuff that you can do from 10,000 foot, particularly in the mapping world, that you can do a lot more effectively and a lot more efficiently from a drone than you can with a manned aircraft, particularly, in law enforcement and first responders. I mean, why does LA need, dozens upon dozens of helicopters when they could put, 1 or 2 LA police drones up at 10,000 feet and do actually a better job than they're doing with helicopters. But I'm not seeing a lot of people working in that space.
What is the most common misconception or misunderstanding when it comes to drones in particular, perhaps military in specific?
Well, for people that don't know drones, is they think they can do everything. They overestimate their capabilities. And whereas, today's drones definitely need pilots, looking after them, and they definitely, require pre-mission planning and all that stuff. For folks that do know drones, I hate to say it, but we do the stupidest things with drones because we get a little bit too cocky with them. I could remember in the Southern Watch over Iraq, the Southern no-fly zone, sending a manned aircraft into Iraq was a big deal, and we'd send fighter escorts and jammers and air refuelers and reconnaissance aircraft and whatnot. But, we got into drones are cheap and replaceable, and, we'd send them in there by themselves, and that would run into all kinds of problems. Again, they're still aircraft, and if you wouldn't send an F-16 in by itself unescorted, the teeth of enemy air defenses, probably don't want to send a drone either.
What's the one point that you would want our audience to most take away from this discussion, from your comments?
Talking to the commercial guys, the one thing I want to tell you is don't give up. I really fundamentally believe that the FAA is going to come up with equitable beyond visual line of sight rules within the next couple of years. We've already got the remote ID rules out. There's a lot of consternation over that, but that's going to straighten out. I really do believe, I'm going to say in the next 3, maybe 5 years, that you're going to face an entirely different regulatory scheme out there, and it's going to really enable what we're doing. The problem is, I know everybody's, got to respond to venture capitalists or whatever, and you need to, see a profit, within a year or so. That's probably not going to happen, but it's coming. The folks that are prepared for it now are the folks that are going to make the most of it when it does come. On the military side, Air Force, please, keep up with the Loyal Wingman program. It's the right thing to do. I think you're going to revolutionize air power. Just don't let the naysayers talk you out of it.
That's perfect. Jim, anything else on your end?
Great. Terrific, General Puss.
Yeah, thank you so much, General, for being on the show. Really enjoyed the conversation and look forward to crossing paths again soon.
Yeah, same here. All right, it's great talking with you guys.
Same here, General
Puss. Thank you. Bye-bye. All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.